bit offline there. It means that rough surfaces will actually, and I need to fix up my cube mapping as well, or rather the MIP mapping, but that's not my fault. I just need to generate proper textures basically. But anyway, it means that light will actually properly scatter off rough surfaces, right? As in like the areas which the areas that we will sample from the cube map will be all scattered if the surface is rough, because we'll have a normal map. And that's very important, because if I was, say, trying to get like cast iron or something as a material, and it's completely, like the surface in terms of how the light reflects off it is completely smooth, which is the case for here, then no matter how rough we make it, like it's just going to kind of stop reflecting stuff, kind of like what you see here. But it's really not going to, and yeah, that cube map's wonderful. It's really not going to, it's just really not going to be able to show the fact that it's like that. What is that? Oh, I guess that's the specular highlight, right? Interesting. No, it's like this black. Is that part of the cube map? It might be. It could be. Yeah, I think it is. Weird. Anyway, that's just kind of the general idea, okay? So in order to do normal mapping, we need two more vertex attributes, right? We need tangents and we need binormals. Now, when I export something like a I don't know, when I export something like an OBJ file, those are not included, right? We get the usual stuff that we kind of want for basic rendering, stuff like position, normals, and UVs, right? Texture coordinates, but we don't get things like binormals and tangents, which we need for stuff like normal mapping. So I finally said that because OBJ was OBJ was just there in the beginning. It was never going to be there like later on, right? It was just something that I put in because I just wanted to be able to load models, right? I didn't want to spend too much time. I just wanted to get some models rendering. So because OBJ is something you can put in like half an hour probably. Now, that being said, the time has come, because of the need for more advanced rendering, basically, the time has come for Sparky to have a custom model format. The reason that I was actually talking with a few people on the Slack, right? So slack.thechannel.com. It's like a messaging thing. You guys should get on it if you're not already. In the Sparky channel, we were talking about custom model formats. Some people had some questions regarding why you would want to do something like that and why you wouldn't just use an existing format. And the big reason that you want your own format is there are so many reasons, right? First of all, you want it because you dictate what data is in it, right? So you can say that a model contains this, right? And when you have something like like model formats will commonly contain data that you don't necessarily need, right? So it's a good idea to be able to make your own model format because it means that you're only storing the data that you need. That's a minor kind of advantage. The big reason you want to have your own format is because you want to because you have control over the layout of that format, right? So, for example, when we look at OpenGL and we look at the way that models are currently loaded in the model class, basically what happens is we construct this vertex list, right? I think it's actually a vector, right? We construct this vector of vertices, which are basically position, normal, and UV. And then once we do that, and we fill it out with the model data, we pass it into OpenGL. Now, obviously, with an OBJ, there's this step, which is us passing, strings, which is terrible, right? Text formats are pretty bad because they involve all this kind of parsing stuff that takes, a long time. And then we have to basically run through this insert vertex thing, which basically hooks it up for us, and this basically is just an indexer, right? It will index the mesh for us. It'll generate our index buffer, and so what ends up happening in the end is that we essentially have, we've rearranged all this data into a format we need, and then only then can we actually push that onto our graphics card, which is what we do here with the set data thing, right? That's not good, because that means that for us to load models, it takes a long time, right? What you want to do is you want to design your own format, which is already in the case of what this is. So what happens is when you read that file into memory, what you can do is you can just give it, like, you know how big it is, you know the region of data that is in that file format, in that file that you just read into memory. You can give it a pointer to the beginning of it, which is what this is, and then you can obviously tell it how big it is, and that's it, right? It's already in that format that you can just push to OpenGL, right, in our case, or Direct3D or whatever you are using, yeah? So that's kind of what you want, okay? And then you can even go one step further from that and say, well, hey, we don't even have to read that data into memory, right? We can just memory map it, which means that it remains on disk, and we don't spend time copying like the entire file, which could be like, 20 megabytes, for example. Or it could be a lot larger, but anyway. We don't spend time copying 20 megabytes into memory and then copying it into our GPU. We can just kind of memory map it, which means we kind of just bufferedly read it straight from disk into that GPU, right? So that'll be blazingly fast. That's the end game. So step one is developing a format that is in the format that we need, okay? Now, I did already start on it. It's called SPM build. Right now it's a tool. So there's a tool in the tools thing, and none of this is pushed or anything, so you guys won't see it. But it's a tool here. I've got two FBX models here. And then I've got this just main thing in which I kind of started all this. So far as it's about 700 lines. This is a lot of FBX SDK stuff. Luckily, I've gotten to the point where a lot of this stuff is copied from the FBX samples. Obviously, I have rearranged it and added it so that it contains what I want. And I will probably still be refactoring this for ages, but the point is I do want to kind of get this done more or less tonight, which is going to be a challenge, of course. But nevertheless, we will give it a shot. So basically, the point where I'm at right now is that if we do read an FBX model such as a cube, yeah, what this little program of ours will do is it will basically output into the console. We're importing a cube. It will actually triangulate the cube or the FBX model. It'll tell us how many polygons it's importing. It'll then extract all the vertices. And then what we'll get is this. What this stuff is that it's printing here is already the vertex buffer. Okay, so this has everything. So this is our position, this is our normal, this is our UV, our texture coordinate, this is our binormal, and this is our tangent. Okay, and you can verify that this stuff is pretty much working by, if you just look at the normal and then you look at the binormal and tangent, you can see they're in the same, space. And then we have an index buffer, which is what this is, okay? So pretty cool, right? And this is how you would expect it to work as well. So that is pretty much the way that cookie crumbles. Yeah, okay. So that's the way that I've kind of done that. So we've got all the data we need. Now we just need to design a file format which actually works, right? So we've got all the data we need in memory, and in fact it's pretty much in the right format. Like if we look at it, what I've defined a vertex to be is this. Okay, a vertex is something that has this vec4 position really needs to be a vec3, by the way, because I don't really have a use for it being a vec4. FBX reads everything in as a vec4 for some reason. That's not something I'm interested in personally, because they're always going to be vec3s. Like as in the W component's always going to be 1. So there's really no need to do anything like that. So I'm just cleaning it up real quick. What was the other error? No, this. Printing it out. Yeah, this stuff is pretty complicated for those of you watching. I'm sorry, it's not really, it's something that isn't really that much fun. But basically what I'm doing is I'm taking a model format called FBX. It's an Autodesk model format. Autodesk is a company which make a lot of great applications such as Autodesk Maya, Autodesk 3 Studio Max, you know, all these 3D modeling applications that are used in the industry. They're industry standard. They have a file format called FBX, which is completely free pretty much. You just have to, if you do use it, the license just states that you have to basically say that your software uses FBX's code, right? That's it. But the point is, it's pretty much free, and it is a file format, and it's probably one of the best kind of file formats that you want to use for actual development, right? Like when you're developing a game, because it just has everything in it. It's got everything. It supports like everything. Yeah, everything exports FBX, like including people are mentioning in the comments, like Blender also exports FBX. Why? Because the FBX SDK is like it's open, right? I'm using it right here. Yeah. So of course anything can use it. There's no limitations on it. It's not just Autodesk products, anything. But the point is, it's a very, very, very good file format. Not so good for actual engine runtime stuff, but then again, no format is. You want to make your own for that. There is no model format. If you're making a game engine, there is no 3D model format that you want to support, right? You want to make your own, okay? You obviously do want to support some model formats just for like previewing and visualization and stuff like that. But when you're actually shipping a game, you want to have your own format. So what I'm doing right now is I'm writing a tool. So this is an offline tool. This isn't something that runs as part of the game. This is when you're developing a game and you have a model that you've modeled and you want to put it into Sparky. You export it from your modeling application as an FBX, right? I may in the future write some kind of plugin that you can export straight to this format, but I really don't care about this because this will be easy to build anyway. What you do is you export an FBX file. You run this tool with the FBX file that you just exported, and this tool will convert and write something called an SPM file. SPM stands for Sparky Model, okay? And you'll get that thing, right? And then that SPM file you can load into Sparky, okay? That is the workflow. And right now I'm right in the middle of developing a tool that is all in one file so far that will just that will convert FBX into a format that I haven't actually written yet. So that's the idea. Okay, so I converted vec3s into. So yeah, it's pretty complicated. It's not the easiest thing to understand. There are a few really complicated things going on here, but overall it should be pretty easy. So that is something like a yeah, like materials and stuff I'm not even supporting right now. All I care about getting done today is I just want my vertex data and my index data. That's it. Okay, I don't care about anything else. I don't care about materials really. Obviously in the future you would want your model to have materials so that all your like the mesh's material properties and like the texture, like links and all of that stuff that it references will also be in the file, but don't care about that now. So yeah, as I was saying, the cool thing is, if we look at this, and this is us, you know, printing, I might even say that we can print this if we're in debug or something like that. Not that I care too much about any of that, but basically we now have an S vertices, we have a vertex buffer and an index buffer that is actually exactly what we need. We literally could just write this out to a file and we would be sweet. And that's pretty much what I'm going to do. I'm not going to spend too much time on this. So hopefully we can actually finish this file format tonight, even though I haven't started it. So I'll be back in a sec. I'm just going to get my notebook because I did a few sketches as to how I want to structure this. Be right back. All right, I'm back. That was quick, right? Got a notebook with the Sparky model format. So let's begin. Make a new file here. I'll call it SPM format or something. I actually do want to rename that SPM writer. I guess we'll put it in this. We'll put in the tools namespace. How about that? This is the first tool that we're kind of writing, so that's exciting, as always. SPM writer. Okay, so this is going to be a tools. It's going to be a serializer that I'm going to write really quickly. It looks like what we will do here is probably have a, I need those classes accessible everywhere, utils. This is very quick and dirty, and I will clean this up when I have time. I just don't right now. I just want to get this done and working because I wasn't planning. This was kind of an unscheduled, right? I wasn't planning on having to design a model format halfway through implementing physically based rendering. Okay, all this stuff, I'm moving into utils. Type def unsigned int. This currently has no relation with the engine either, so it's also exciting. Yeah, well, we'll like obviously the ordered map. Where is hash? Hash would be in there, yeah. Okay, that seems to be it. So we'll include utils. All right, so we could probably just, yeah, I'm not gonna write horrible code here, but I will say that we'll have our vertex buffer, which will actually just be probably a, these will both be references. Vector. So we have vector of vertex. Let me just quickly also include, what am I doing? Include utils. All right. So we have that, and then we've got our uint index buffer. So this is pretty cool stuff. We will have and they'll probably be more or less const. We will have a hash is probably in algorithm. It's just that our unordered map obviously will include algorithm. So, well, it'll include hash anyway. So, yeah, it looks like it's an X hash. I'm assuming it is, yeah. I just need that for the unordered map thing. Because that's my super awesome hash function. Anyway, enough of that. SPM writer. So we're going to take in two things. We're going to take in our vertices and our indices. SPM writer. Okay, so write const string file. Let's quickly go to utils and type def a string. Sorry guys, I'm going to be working as fast as I can because I really have to get this done today. Otherwise bad things are going to happen. So we're going to write that, and that's it. Struct SPM format. So we're going to have, of course we need, and in utils we're going to need a type def unsigned char byte. So header 4 bytes. Let's see what we got here. We got header and we got name. Okay, so char name byte. It's gonna be a 256. Name will be enough, yeah. Byte name length. name. Then we're gonna have a bunch of objects. So we need some kind of index, I assume, that will actually exist. Not for now though. So properties, we need, yeah. So we will eventually also have some properties. I'm looking at my notes. Okay, then we have data. So, short, we might as well have a uint here. Uint, VBO size, vertex buffer size, we'll call it. Uint, index buffer size, byte, vertex data, index data. We also need to really have some kind of, I didn't write this in here, but we do need to have some kind of mask of things that we support. So attribute bit field, something like this. Enum vertex attribute. Define bit x. Where was this? This was in common, I believe. Copy this. I really should be referencing Sparky, I think, in this library, but I almost don't want to just have that dependency. Oops. I almost don't want to have that dependency, that's all. Okay, so vertex attribute. So let's see what we got. We've got a position, normal, UV. So this is going to be a nice bit field so that we know what we actually have. Tangent and binormal. Again, pretty primitive right now, but that's all I kind of need to support for the time being in this format. In fact, I can probably just char header equals SPM 0. Sparky model format. Oh, we can go FBX Sparky model format. Happy with that. Okay. So that's our header. Okay, cool. So let's see what we got. 1, 2, 3, 4. We have an attribute bit field, so then we know what we got. We've got a vertex buffer size. Yeah, okay, cool. And then we have stuff like materials. Also, when we do objects, meshes should have a material index. Okay, done. That's all I care about right now. So this is the format that we've got. We're going to construct that format, and then we're going to write it out. So let's quickly create method implementations for all these. Okay, so vertex buffer, vertices, index buffer, indices. This is not right. This is uint. Okay, SPM format. So, here's what we need. We need a name, const string name, and name. I have heard of Amazon's new game engine called Lumberyard, which is, yeah, just CryEngine with AWS and Twitch integration. What's wrong with this? The other thing that I need is I need to know what I've got. So, int attributes. Fortunately, I'm going to have to know what this is. So this is like flags, essentially. Okay. So, where was I? Well, yeah, okay, so format. I can kind of create the format almost instantly anyway. Should I just do that? I probably should just do that. What's in the format? Yeah, I don't want to do that because of a few reasons, but we could. Here's what we could do. We have all the data in the constructor anyway, so void SPM writer construct. Yeah, okay, we'll construct it here. So, M format, we can set a few things here. First of all, the attributes, for example, attribute bit field. I'll just call this attributes. I hope you guys. Bit field. Attributes, name length is name dot length. Name is what now? Char pointer. Okay. So yeah, I'll just throw it to name because it'll get copied anyway. Name 0. What else can we fill out? I guess we can fill out the vertex buffer stuff, right? So vertex buffer size is vertex buffer dot size, index buffer size, index buffer size, vertex data is vertex buffer 0. And index data is index buffer 0. So we've got pretty much everything we need, I think. That is everything. Yeah, that's it. That's our entire format written. Fantastic. And then I guess we'll have a footer. Just so that we can verify the file got written correctly, I guess. 1, 2, 3, 4. Why not? Okay, so right. Writing files. Okay, so include. What do I need for this? Standard lib. File equals fopen. I'm gonna have to put in that macro to stop stuff from happening. File. That's not a. Yeah. Mode write binary. Okay, so this will be. The cool thing about this is we really don't need much information about the format, like whatsoever, which is fantastic. In fact, if we've just got this, we know everything we need. So it's actually going to be a really compact format, turns out. Let's just, okay. Close file. So file, how do we write a, yeah, how do we write a buffer quickly? Buffer. We can do, yep, okay, right, buffer. Okay, F right. So F right is what I want. Here it is. So let's take a look at this. So we got the pointer to the array. Yeah, we got, okay, size in bytes of each element to be written. Why does that matter? So basically 1. Count the size. And, oh, that's right, we also need to keep track of the size. Yeah, okay, that's a bit annoying. I mean, we do know the size. I was hoping we could just dump the data. We can't. Okay, cool. Why is this not happy with my file? Oh, right. F. Okay, let's quickly compile this so I can get rid of that error. So all configurations, preprocessor, CRT, secure, no warnings. I could probably just use the S version of it, but who's got time for that? Not me. All right, so let us continue. Okay, so what can we actually write? Not much, right? We can write, yeah. It's a bit annoying. Because we're gonna have to, yeah. The size is fine. I think I can just do, I can get away with, I would love to have just done F right and format 1, you know, size, whatever, how big it is. But I can't do that because it's made of pointers, which is not exactly what I want. So anyway, I guess we'll write the header. Does that have an offset? No, it doesn't. Just got a byte pointer equals. We can just point it at format. No, that's probably not a good idea. This is a file pointer, isn't it? Oh, hang on. This is annoying. Surely this returns total number of elements successfully written. Yeah, okay. Oh, okay, so it keeps track of that stuff for us. That's right. Okay, that's fine, actually. That makes our life a lot easier. So we can write format.header, which is 1 size of head. Well, we don't know that. It's actually, it's 4 bytes, but I don't really want to. Void. Right. Byte data, uint size, file. Just clean this up a bit because I don't really care about some of these parameters. Call it write bytes. Yeah, we'll just do that basically. So file. Data size. So write bytes. File and format dot header 4 bytes. This is F. Oh, I'm gonna have to. This is going to be so annoying. In fact, I could probably just template this. Don't really want to do that. Yeah, doesn't matter. I don't care. We've got the header written. Let me quickly pull this out. Name length, that's a single byte, which is nice. So name length. I'm gonna copy this a bunch of times. Yeah, okay. Name length. Then we've got the actual name. So that's gonna be fun. So M format name length and M format name. This does not need to be a thing. Attributes, 4 bytes. I should really do this instead, if I know how big it is. Again, bytes. Vertex buffer size, which is just going to be the same as that. Vertex data. Okay, so this is a big one. So this will be M. Oh, no, we don't need to do any of that. Yeah, it's already there. This will be. Oh, it's already a. Oh, well, that just makes life easy. So M format dot vertex data, and the size is going to be M format dot vertex buffer size. We're going to do the same thing, I guess, for the index buffer. And then we got the footer. Well, this is easy so far. Hopefully it works. I mean, it should. Index data, that will just be, oh, sorry, footer. That's just bytes and format footer. One thing we should really have done is this, to be honest, because we don't want to keep referencing that field. Format, current selection. All right. So we got the format, and there's going to be a const as well. This footer, and it is 4 bytes. All right, done, I think. That's complaining. What is that? The name length, which is a byte. Why on earth are you complaining? There we go. Okay, so what up? Do you really need the name length? As a C-star strings was null terminated, isn't that enough? Yes, I'm not null terminating it. Like, I don't like to have my strings null terminated when I'm writing in serialization format. I like to have the size and then the bytes. You could have it null terminated and then, yeah, but I kind of like when I'm reading files and when I'm reading streams of data, I like to know how big the name is before I read it, because it's actually pretty common for me to be like, actually that description for if it's a string description and it's like 10,000 characters, I might be like, you know what, we're going to skip that and we're going to just go to the, you know, we're going to point to after that, and we don't know that because we have to keep reading it to get to the null termination character and be like, oh, that's how big my string is. So I'm not a fan of that. I like doing this instead. Okay, let's compile this and let's run it. I mean, I don't really know what's going to happen. Presumably it's going to work. I'm going to open up my hex editor. This is going to be extremely difficult to actually debug because because yeah. So where are we? Let's try it. So SPM writer, let's include that. SPM writer, this is in, presumably this whole thing will be there. I really need to, we don't even need any of this. All right. Apparently we do. Ugh. I don't want to have that at all. A lot of this is copied straight from one of these samples. There's a sample called, if you install the FBX SDK, there is a sample called Viewer, I think, or something. It's like the very last one. Oh, that's not it. That's the one in Sparky. It's this one. So if we look at it, there is samples and there's view scene. That's what it's called. This, if you look at this, this is pretty much the same. I literally copied and pasted a bunch of code from it. Like I went through it and extracted the code that I actually need, and just jammed it in here. All these comments are from there as well. And I extended it quite a bit as well, but that's pretty much it. So there's nothing too magical here. Anyway, we'll create the writer. It is called SPM writer, right? Why are you lolling me? SPM writer. Oh, we need to set the attributes. That gets set here. Static uint s attributes. Again, this obviously needs to be not just C style static, like globals. Well, they're static, so they're not really global. But I know that this needs a lot of work. I just don't care enough right now. Why are you not working? Where's am I using namespace? Oh, I deleted it. SP tools. All right. Yeah, there we go. So name. The name is going to be this. We're going to do a few things here. The first thing we're going to do is we're actually going to move our command arguments. We're going to move this into here. So if arg c less than 2, return -1 usage. I don't care for now. Okay, path is going to be argv1. All right, so now that we've done that, we want to have a static string name. Why are there so many errors? There's not. Okay, good. Name equals path. Just for now, we'll just do that because I don't really like. We'll probably there'll be an optional thing to pass that in. Okay. Okay, game programming question here in the comments. I like my first part. If you're talking about the game programming, not that I think 3D game programming is out of date because that's just it's not a very good series. Game programming, on the other hand, I would not say it's out of date, no, because it's like if I rewrote it, I might explain it better, but it's still very relevant. It'll teach you how to write your own renderer, basically, like your own rasterizer and everything. So it's a good series. It's not out of date. Name. Okay, so we've got a name, then we're going to pass in the attributes, which right now, which aren't set actually. Vertices, which are going to be just S vertices, I guess, and then the indices. All right. And then we'll do writer.write, and we'll say s name. Well, no, we'll say something like model.spm. All right, that's it. So I want to set the attributes though. So let's do that. Why is this just not even working correctly? Visual Studio sometimes. I swear 2015 is a bit dodgy sometimes. Okay, so we're definitely going to have a position. That's impossible for us not to. So, we only support one mesh object thing right now, which is very important. Because that, yeah. So anyway, if has normal is true, okay, so we basically just have to do this. We can do binormal, what is it? It's just binormal for now. It's pretty awful. We can literally just do that. So has tangent. We do need to set this to 0 though. Otherwise that'll be a problem. Okay, so where were we? Up here. Has UV and has normal. Position is going to be true anyway. Okay, so at least we know all this stuff now. I think this might work. So let's just let it run, and we'll hop on over to the writer and see what happens. Okay, so over to file. Write bytes. So header. Name length 17. 17. Oh yeah, that makes sense. Yeah, I buy that. We really should format the name properly though. Attributes 65814. That. Yeah, I think that's correct. That is way too high. What? Hang on. Yeah, that's correct. I think. 6.5. 16. No, that's wrong. That's completely wrong. Why is it? What? Why is that? That's wrong. Yeah, that's completely wrong. 6.53616. Why exactly is that wrong? Ugh, never mind. We'll fix that later. That's wrong though. 65814. Oh, unless it's... Oh. Hang on. Yeah. Yeah, you're wrong. I'm wrong. What have I done? No, wait, that's... No, I'm right. Where is this code that I wrote, first of all? Oh, no, I'm not. Yeah, no, I see. I see what I've done. That's not what I wanted to do. What am I thinking of? No, that is 1. I just thought that this would be like 2 and stuff. Which is a bit annoying, actually, that I did that, because it's a bit terrible. I mean, the alternative is doing something like... I don't even know why I wrote that system. That's a bit weird. I could just do this. But that's a little bit dodge. I don't know. This should probably work. Alright, let's go back to here. Okay, 31. There we go, that's correct. Anding it would not have worked, because M has normal is going to be either 1 or... I don't think it's going to be a full byte. I think it's just going to be 1, which means that 1 and, 16 or something is going to be... It's going to be 0, so... Anyway, vertex buffer size 24. Oh, I don't like that. No, I'm wrong. I'm completely wrong. That is so wrong. Sorry, this is supposed to be size of vertex. And this is supposed to be size of uint. This is better. So, if we just, first of all, see what the size of a vertex is. Where's my size of the vertex? It's 56 bytes, which is correct. So this should be much, much bigger. 1,000. And the index buffer is 100. Alright, well, we just wrote out the file. So let's see if the file is correct. I mean, it should be. I don't think I screwed up much. Okay, where are we? Tools. SPM build, model.spm. It's 2 kilobytes. Seems about right. The FBX was a lot bigger. The FBX that I'm using is 14 kilobytes. This is ASCII though. I specifically exported it in with ASCII so that I could verify that the data was correct. But obviously you would be exporting it as binary. Furthermore, like, these files could definitely be compressed anyway. Okay, let's view this in... First of all, yes, it is binary. Good. I didn't accidentally write text. Second of all, let's take a look at this. So, what have we got? This is going to be, again, as I said, this is going to be impossible to read. SPMF, we've got the dot there. That's the length of the name. 17, it should be. SPMF. It's 11, which is 17 in hex. Yep. Then we have, I can't even remember this thing. Sorry, I'm just really tired. SARS. What's next? What am I looking at? Attributes. So 4 bytes of attributes. Starting here. 1F. What? What is even that, man? That can't be right. Let's take a look at attributes. I can't think right now, so I'm not gonna pretend to think. Yeah, okay, that's right. It is 1F. No. Accidentally started writing it again. 1F, okay, good. We've got the little @ sign there, which is the beginning of our vertex buffer size, which is that many bytes, apparently. Okay. Then we begin the vertex buffer data. That doesn't look good at all. Wait, why is that? Is that because... I think that might have been because I'm reading the file. Yeah, there we go. Look, I'm gonna just buy it and say that it worked. Sorry for that hiss. Where did my phone go? I'm just gonna say that it worked because I can't be bothered actually checking. All right. So, done. We can now export FBX files. Let's try something a bit bigger. So, as I mentioned, that model.spm thing was... Sorry, we did a cube which was 14 kilobytes. Let's try something that was 1.6 meg. That should be big. And let's output that as something. So if we go over here to properties, we change the command line arguments to be, and this is in debug mode as well. So once we compile in release mode, it should convert this stuff a lot faster, but we'll do sphere ASCII. And we will also go to main, change this to sphere, and run it. See how long this takes. Probably quite a bit of time, I imagine. That's alright, it took like 4 seconds. I mean, I wouldn't expect it to take that long. There's our sphere, it didn't crash. Let's take a look at what that looks like in hex editor. We've got SPM, we've got res sphere ASCII, and then we've got a lot of data. Look, I'm just gonna, and then we've got our 1, 2, 3, 4 footer. This stuff is very difficult to verify because obviously it's not string data. It's just a bunch of floats, really. So I'm not going to pretend to read this. Decimal. That's just the thing. Yeah. All right. Whatever. All right. And it's 200 kilobytes. That's fun. Let's now. So this is that's kind of done. In a way. We probably want to give it an output. Where is string utils? Split string. This is a header. We could probably just include this. I'm going to just be all dirty and include this. So. Who am I kidding? I have no idea what this is. 1, 2, 3. That might be it. Sparky core. Source. SP utils. String utils. Checks out? Yep. Checks out. So, and that, what namespace is that in? Utils. I just want to use a string split because when we get the path, here's what I want to do. I want to say I want to say that I'm going to split string, the string delimiters slash, / backslash. Does it do per character? Yes. Quickly just verify that. Oh, no. No. Mother duck. Sorry, guys. I know this is bad. Okay. Path. Load scene path. What does this actually do? Yeah, about the file name. Nope, we don't actually need it even. But I will still keep it in there. Alright, see if this worked. Hopefully it did. What the absolute shit happened here? Oh, this. Yeah. Okay, this will be the output name. So I'm basically working on the output file name right now. So s output path, we'll call it. So we'll set the name to that, and then we'll set the path to be basically I could be a little dirty with this, but I don't really want to. Split string path.fbx first. What's the first one? Front, is it even that? I guess so. Front plus SPM. Don't know what this will do. Well, I do kind of, because I wrote it, but that's not the question. Oh, that's controversial. No, we don't want to do that. We just want to do that. Okay. So, output path. The reason I've done this, guys, is because I want to be able to do something like this. Sphere ASCII. I want to be able to just drag it on, run it, and I want it to output like that. And as you can see, that worked. Okay, that's what I want the build to do. I also don't want it to pause at the end. Okay, so that's debug. Let's try release, because I've got a lot hinging on release here to be a lot faster, hopefully. Not that this is the fastest one I've written. This is take one, release mode. Maximize speed, inline function, any suitable, favor size or speed, favor fast code. Yes. Code generation, enhanced instruction set, SIMD, please. Floating point models fast. Apply. I think that's about it. Yep. Got optimizations on. Yep. Let's build that. So let's quickly time this just for reference to see how long this actually takes. What have I done? No. What did it build to? Wait, no, that's correct. What? Oh, right. Build, release mode. Oh, lol. Apparently I forgot to link it. Yep. Oh, it's not going to be... Oh, that was the debug library as well. Let me tell you. That was the debug library. This should be much faster. Dependencies, FBX. Now, I believe the good one is probably that one. What the fudge? We're just going to link against this one. This one clearly isn't the debug version. There's also a DLL here as well, which I'm not interested in at all. Let's do this and see what happens. Release. I actually don't know if this will link properly, but we'll give it a shot. No, it won't. What are the different libraries? Documentation reading time, I guess. Or I could probably open that sample again. FBX SDK. Samples, view scene. I really don't even have to open it. I just want to open it in Sublime Text so that I can read what it links in release. Release Win32 non-DLL, please. Release Win32. Okay, that doesn't help me. User macros. Okay, whatever. Release Win32. Okay, it's here. I can feel it. Additional dependencies. Okay, so they do use MD still. Isn't that the debug one? No, I guess not. Okay, if they say so. I don't know why I changed this to release, by the way. This should be debug because I didn't switch my configuration. Okay, this is the include directory. This does say release, good. And this should be set to... How is it not set at all? What is going on here? I'm not even building the right configuration, that's why. Okay, apply. Let's see if I can actually link against that, because that would be lovely. No, I can't. That's release. Definitely release. Okay, so we'll try MD now. Okay, that seems to work. All 838 functions were compiled because no usable. Yeah, that's... okay. You saying that out of spite? Not all control paths return a value. What? Isn't that a void? It's a bool. Are you now? Okay, well I guess we can return true. If it got to the end. Just heal up that warning real quick. Alright, cool. So, now we can do our exercise. So, debug. If we have a file, like a sphere. Sphere's going to take a while. Let's see how long it takes to build. 1, 2, 3. I'm going to say 4 seconds. Now let's go to release and see how much faster this is. Hoping a lot. Okay, that was instant. Great. So we can build pretty quickly. That's good. So the way you guys build these files is you can either open a command prompt and be like, hey, SPM build. I want to build this sphere ASCII FBX file. And then it will just build it into, I'll probably add more logging. It'll just build it into the same thing the same name but and .spm, or you can do it the pro strategy way, which is just dragging your file onto the build.exe and it just builds it. Okay, done. And that's it. That's all you have to do to convert from FBX to Sparky model. Okay, okay. Done. MD means multi-threaded DLL. Oh, here we go. E-play haters in the house. All right, so if that's the multi-threaded DLL, then why is there a really, really, really small lib that's just like 4 meg and then this one's 70 meg? Like, clearly there's something missing here. I mean, I guess this could be the one that doesn't statically link and it's just the dynamic one that uses the DLL, but no, it's not because it didn't link at all. So I don't know. Anyway, I should really read the documentation. Okay, cool. So, oh, that would be why, yeah, my CRT probably wasn't set up at all. Where even is that? No. It's one of those things that you just never set. Or I never set, at least. It's somewhere in here. Okay, anyway. Oh. All right, cool. So that's done now. Now we just need to write an importer in the actual Sparky engine that does it. So this is not too bad. This didn't take me too long. This is probably about 3 hours of work. So I'm pretty happy with that. Luckily, the samples that came with FBX were actually pretty good, and I just slapped it in there, just copied and pasted some code, and we're running. So that's good. Let's go back to Sandbox. Okay, so a few things need to change pretty much straight away. We need to change our model file to no longer use. I can't do a quick commit because I'm on versioner, not on Git. So sorry. I will soon, probably, maybe not, soon-ish. Think of this as a secret branch. Okay, so let's rename this model CPP file. Where is it? Let's rename this to obj model.cpp, and let's write another implementation. And let's not compile this one. Excluded from build. Yes. No, let's not do that. Get out. Let's just if 0 this whole thing for now, because I have no need for that. All right, let's write another model. Model. What else do we want? Yeah, I mean, I don't know. I guess I probably should have copied and pasted it, right? Like, because it's going to be kind of the same, maybe. We don't have like anything. Oh, right, because I didn't include model.h. That's what I was trying to include that time. Load. So that's gone now. We don't need any of that. no more string parsing for us, thankfully. None of that. Okay, cool. So, and we set it to a material. So we're not loading the material from, sorry, microphone. We're not loading the material from the file just yet. We will in the future. And unfortunately, I think we need to actually include glue for now. Well, yeah, that glue, not the GLU, old ancient thing. All right. That's what my phone is. Okay. What am I doing? Oh yeah, the import thing. Oh. Where's my SP writer? Why is it not showing up? Okay, let's quickly grab this. I will set this up properly one day, but it's just not, I'm not doing that now. As I've mentioned 1,000 times, but it's just because I'm doing a lot of really bad stuff. That's why I'm complaining to you guys, kind of. Okay, so, that's all I care about. Load. Okay, so we're going to want to open a file. Open. Path. Read binary. Okay. So we've got a few different, like, we've got a few different options here. The best option is going to be, I guess we will be putting this into mesh anyway. Oh, this is good, yeah. The best option is going to be, like, eventually the best option is going to be to probably just like memory map this thing so that we don't actually have to load it, because we really don't care about this data at all. We just want to shove it into the GPU and be done with it, to an extent. So since we don't have any kind of file system or memory mapping capabilities, and I don't care much about that right now, I do a little bit actually. I do quite a bit, but I'm not going to do that now. We're just going to basically copy it into memory. Well, copy it into the appropriate spot in memory, not just read the whole file and then deal with it. We're just going to copy it exactly. We know the format, so it should be pretty easy. Where's fread? That's what I want. Fread. Okay, so we've got the, just reading the documentation for fread, fread. Okay, that's okay. All right, it's pretty simple. We make that format thing. This is going to be really annoying because we're going to read it like, maybe it's better to just read the whole file straight away rather than buffer by buffer, because maybe we could read a bigger buffer. No, I don't think it is. No, let's not do that. So let's try and read the header and make sure that it is SPMF. So fread, what do we need? We need a pointer to block memory. So that'll be our header. Of at least size times count byte. Okay, whatever. Size in bytes of each element. That's always going to be 1. Read bytes. File. Uint. That's going to be a position, right? Or is it just going to be stream? Can I not tell it how much I want it to read? Why can't I just be like, I want to read this much? Oh no, I can. Yeah, good. I was gonna say. And I guess it just advances it to the position indicator, which means advanced by the total amounts per bytes read. Okay, cool. So now what am I doing again? Yeah, okay. File and size. And it will basically say, I kind of feel awful making a buffer that big. That's fine, I don't care. Memory allocation all over the place here, but oh well. So size is size, no, buffer is buffer. Size is, element size is always going to be 1, element count is going to be size, string is going to be file, return buffer. We'll do it this way for now. So, byte header equals, there's going to be so much, this is pretty terrible. Anyway, byte header equals read bytes file 4 or F4. So let's quickly just do it. Assert header equals, is this even gonna, no it's not, hang on. String compare, string equals, I don't even know how to do this, C. String compare, yeah. So what does it return? 0 if they're both equal. Okay, good. So header format.header equals 0. All right, next block. Unfortunately, we are going to have to delete this every fucking time, which is why I did not want to do this. We do need to have some kind of buffer that just like is actually good, like an actual buffer that so that we can read stuff. But again, I'm not going to set this up properly right now because I don't care. Well, I do care, I just don't have enough time. I need to go to bed in like 20 minutes. So, what's next? Name length. Okay, good. So we've read 4 bytes. So this is it. So read bytes. So we're gonna read the next byte, which is then hopefully going to be name length. So format dot name length equals, this is probably not the best way to read a file at all, but whatever. Reading is always harder than writing. What am I doing? This is a byte, yeah? So that's correct. And we've got the name length now, so we can just do something like buffer equals I really hate this. We should be giving it a buffer. That's what's wrong with this. Because otherwise it's the worst. So like for this header, for example, I would have just done something like that, because I know how big that is. And the reason I'm saying that is, well, there's a few reasons, but the big one is that it means that when we read something like there's always going to be cases in which we actually need it, such as this. But there are cases like, oh, yeah, well, it means we can have it on the stack, but also there are cases like this, or not this, but the one coming after it. No, in fact, like this, where we can just say that, we can actually just say read bytes f straight into format.name with a size of format name length. Okay, what's wrong with you? Yeah, that's not actually true though. Just stop being a baby and read it in. Okay. Done. So that's the name done. What's next? The attributes. Okay, good. So we'll do another one of these then. Buffer for read bytes. Attributes. So this is file f buffer for, and then we get our attributes. So format.attributes equals, let's see, this will be format attributes equals uint buffer. All right, that's our attributes. Vertex buffer size is next. So this is going to be the identical pretty much. Vertex buffer size. I'll also do index buffer size while I'm at it. See, it's exactly the same. Now, this is where we need to read the actual data. So this is going to be fun. So in this case, we make a buffer. We don't know what the buffer is going to be. Oh, no, we do. So we make a new, this will be on the heap. Obviously it has to be, it's too big to be in the stack anyway. Format dot vertex buffer size. Vertex buffer size. Oh no, we don't need the buffer. Here's what we do. We say format dot vertex data equals that. That is our buffer. And then same for index data. What? Index buffer size, yeah. All right, and then we have, that's it, right? And then we've got our footer. So I guess we'll just verify that we're actually at the correct point. So footer should be 4 bytes. All right, done. Okay, let's if 0 everything else. Compile this puppy. And then let's go into test 3D. See if we can load a model. Unexpected end if. Oh, really? How do you not expect that? Oh, is it because of that? Those pesky precompiled headers. All right, so this is the big one. So model SPM, or yeah, we'll call it SPM equals new model sphere dot ASCII dot SPM. What else do we need? Material. So this will hopefully work. Let's grab our SPM file. Let's put it into Sparky Sandbox or res sphere ASCII. That should be there, right? Let's see. Hopefully this works. All right. We're in release mode. That's not good. Okay. From byte to... Oh, you can't really. Well, you're gonna have to try. Our asserts are set are so hard that they didn't even compile. That's not good news. All right, so we open the file. We read bytes. Did the assertion succeed? It did. Good. Never been happy to see an assertion succeed. Never been happier. All right. Format name length is 15. Ooh, that's wrong. Isn't it? It's supposed to be 17, isn't it? Well, let's see what the name is. Yeah. Bum, bum, bum. Where did we go wrong? You know what, we should really try reading that cube first, I think, because it is much simpler and it's much smaller. So let's see, cube. Okay, that did not work. Why did it do that? That's so weird. All right, whatever. So here's a cube. Cube.spm. So it seems to have read the header fine. But then the name length, if it doesn't read correctly. So what's wrong with that? It's a 1 byte, right? Let's see what it actually is. HXD. cube. It's D. That's 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that is correct. So then why does it fail in reading the name? Oh, wait a minute. Because we didn't allocate that. I forgot that the read bytes function doesn't allocate memory. Lawless. All good. All good. Wait, what is format name? It's a char. Okay. Okay, false alarm, guys. Everything's still fine. Nothing is wrong, except, well, except my programming, but we'll ignore that. We'll let that one slide. Okay. All right. Name length. Name is. Oh, it's wrong. Why? Why? That's bad because that's going to corrupt pretty much everything. No, that's right. Oh, there's just no null. Yeah, you're a funny one. That's okay. There's just, yeah, I forgot that. Yeah, all good. All right, good. Attributes 31, that is correct. Vertex buffer size, sure. Okay, I'm just gonna assume everything works. Fantastic. So we've read our format successfully, which is, you know, I mean, good. So see, the thing is, now that we've read all that data, all we have to do, this is the beauty of it, all we have to do is say that we're gonna set our data to be format dot vertex buffer size, right? And then just format dot vertex data. Now it's important that we match up the vertex data with what it actually is, because we haven't done that yet. Okay, same way, I can't put, this is kind of the other way around, which is fun, but this is going to be format dot index data and format dot index buffer size. I think that's the right way. Yeah, it's data first and then thingy. So that should just be a, it will be uints. Trust me. All right. In fact, we should probably verify that. This is actually going to cause all sorts of problems because, whoa, what now? What? But this worked before. Oh, no, it's fine. It's fine. It's because I'm trying to load the other ones that don't exist. Yeah. No, but we didn't get to here. What? Hang on. What are we loading? Yeah, that works. Why did it not work before? That's scary. I don't like that. I wanted to go into here just so I could see the data. Well, of course the first one's... Okay, data. Show me like 100 values. Yep, that's correct. So there's our index data. Whoa. Oh, so much potential. Oh no, that's it. Man, I really, my heart skipped a beat there. It's because there's only a count of them. So there you go. Which is 36, I think. Yeah. Okay, all good. All good. Whew. So Well, yeah. So these buffers have a few more a few more things. They've got these things called binormals, and they've got tangents. Okay? And that's it, and they're both vectors. So, the other problem is that my definition of a vertex 3D, no, just a vertex. No, that's wrong. I'm just worried that, yeah, it'll be SP graphics, that's right. I'm worried that somewhere I've got a bad definition. Yeah, render a 3D vertex. I don't know where this is used though. It's used in Mesh Factory. That's it. Well, and Mesh. Oh no, Model, which we don't care about. So, now these are kind of optional as well because we have attributes, but anyway. So this builds, which is good. So now, I guess the next step is to display it on the screen and see if our and see if our thing is working. If our, yeah, I'm not even gonna finish that sentence. I hope it is though, because it would be quite nice if it was working. Now, to see that though, we have to do a few things. We either have to convert all of our other OBJs into SPMs, or SPM keeps, I just keep thinking of like scroll per minute or something. It's really annoying. So we'll pretend that SPM is our, where was that rounded cube? Wait, this was just a cube. I guess we can load a sphere as well. So where is our sphere? Sphere model. So it was, let's change that to be a sphere ASCII.SPM. I really need to install Maya or something, which I don't have here. Because I need to, okay, that is retiring for now. Yeah, these spheres are fine. Luckily they're, oh man, I really hope this works. It should. I mean, I set up the vertex, I set up the vertex buffer layout correctly to accommodate for everything. So it should work. Let's just search for the OBJ and see, make sure I'm not missing anything. Oh, I'm not. All right, I don't think I am. Ready, guys? This is the moment of truth. 3, 2, 1. Action. Pretty nervous. Oof. See, there's that assertion again. Where is that coming from? I'm gonna just say that the sphere was incorrectly built. The sphere is just probably outdated. That's gotta be it, right? Let's build the sphere again. It's looking pretty unlikely, unfortunately, but let's also call it sphere. I just don't understand what's wrong with it. It's not passing like our very first test. So sphere, what's wrong with you? SPMF? What? That is correct though. How is that an assertion failure? And the cube worked, right? Where's the cube? Or maybe it didn't. Oh, there is no cube. Oh, good. Really? There's no cube anymore? No, there's no cube. We are loading a cube though, that's a bit dangerous. As in where, yeah, it'll be a null reference. So hang on, how is that an assertion failure? I don't understand. Oh, because it doesn't have a null termination character, thus the string compare probably can't compare the strings. Oof. Yeah, your header needs a null terminator. Yeah, thanks guys. I was hoping to not do that though, because I don't really care. I don't really want to have it. I guess I'm just not going to use string compare then. I can probably just compare memory, right? No, what is it? Mem compare. I use this so rarely. Mem comp, yeah. So, header, format header, number of bytes 4. 0 means they're equal. Okay, solved, hopefully. Oh, see, this is actually probably a problem. They are the same though. Why? Oh. Oops. False alarm. So many false alarms. Come on, work. Ugh. So close, I bet. Okay, this is not good. What does push buffer do? Some important stuff, I assume. Okay, cool. So this is, yeah, not so nice. Let's quickly go to SPM writer. Size of vertex, position on V1 or tangent. 33233. 33233. Okay, that's the same. What's that name used for anyway? Whoops. Oh, this is all templated. Name, layout, pushback, size. No, that should be fine. Values of 145,000. And then there's all data. Well, it would be nice if we knew what the issue was. Can we get up to the index buffer stage, or does that not work? What's the size of the index data? 58,000. 58,000 indices. Does that sound right? That sounds very high for a sphere. Let's just load the cube. I think the sphere is going to complicate things. So scene add. Keep that in there. New model cube.spm material instance material. Oh, of course. No, it needs to be an entity. Holy crap. So much code required to draw something. I need to refine this API quite a bit, I think. CE, cube entity. Get mesh. Oh, I don't need to do that. That's what I wanted. We add a mesh component to our cube entity. And then we add it in. All right, let's see if this works. So F-read did not work. For what? For that? Okay. So, but it worked before, didn't it? Cube. Odd. Odd. I was trying to read the header and that failed. Why exactly? Are we loading this more than once or something? Where? This is a bit weird. So, load. Let's just make sure that we're not doing that more than once. So, okay, so it does fail here. Oh, all right, let's step through this. We should probably print out the file size as well. So now that doesn't work. Why is it so inconsistent? Wait, what's the path? Oh, no, that's wrong. Just verify that. Yep. All right. So the file does not exist. Good. I was going to say. It's red/cube SPM. So does that work? Yes. And then that doesn't. And where is that? Oh, in the cube transform. Okay, I don't care about any of this. Yay! Look at that, guys. The very first SPM model. Look at that. How awesome is that? Maybe not so awesome because that does not look right. Whoa. Yep, that's wrong. Oh, wow. Almost right, though. So there is a glaring error somewhere here. That's very, very bright as well. I don't think we can control much of this. But hey, we got it. All right. So that's good. It feels good to have done that. But on the other hand, it's not actually working correctly. So that's fun. I wonder what I've done to make it not work. We could probably verify the data manually because it's a cube. It's not that difficult. So if we go to main in our converter, set that as the startup project, switch to debug mode, yep. And make sure that, what was I making sure? Oh, yeah. Okay, let's do the cube. I mean, it looks kind of correct though. Like maybe I'm reading it wrong or something. I doubt that though. Like maybe I'm writing it wrong, but I don't think the data from FBX is wrong. Because let's print it out. So this prints it out. So those are our vertices. They're all at -5 and 5, which is good. That's correct, because I made my sphere, my cube 10 by 10 by 10 when I made it. 0, 1, 2, 0, 2, 3, 4, 5, 6, 6, 5, 7, 8, 9, 10, 8, 10, 11, 12, 13, 14, 12, 14, 15, 16, 17, 18. This is correct. This is correct. So let's see what indices get submitted to the index buffer. Index buffer. Index buffer. Okay, so this is what I'm interested in. So first of all, 144, does that work? Is that correct? 144 divided by 4. 36, yes, that is correct, good. Let's look at what the data is. This is, okay, so it is correct. Let's look at the vertex data. Size of view end. Wait a minute. Wait a minute. Wait a minute. I think I know what the problem is. I think count. Yes. Count. You bastard. Count is the number of elements, not the number of bytes. Who does that? Me, apparently. That is just asking for trouble, dude. No wonder, that's completely wrong. Oh, that's appalling. This might work. Yes. There we go, ladies and gentlemen. We have done it. Let's test the sphere. This is the moment of truth. Cubes are easy. Spheres not so much. I'm actually pretty impressed that I was able to do this entire thing from start to finish today in like probably a total of 4 hours. 4 to 5 hours of work. Possibly less. Like from scratch, like from the FBX, from not having any importers to just having an importer and exporter for file format in like 4 hours. I'm actually pretty happy with myself for being able to do that. With no idea what the file format would look like either, just on the fly. And somehow it has worked out for my favor. So yay. All right, let's enable this. Let's enable our spheres again. Yay! So they're bigger than the other spheres. They're bigger than the OBJ spheres, but they are spheres nonetheless. Awesome. Model format complete. Well, complete is a very big stretch of the word, but more or less complete. Now, look at that loading time as well. I mean, sure, sphere isn't a big model, but loading time is pristine. Let's make them further apart. Even more so, apparently. Wow, those are huge spheres. Those are very massive balls. That's probably too much. All right, job well done, Cherno. Job well done. All right, so we got our balls, and they are correct, which is good. We can control the color of them as well. Maybe not. No, we can't control the color of that. Or that. Oh, it's because I it's because I nuked everything in update. Oh, and also the cube is not going to work. Let's put that cube back. We definitely can. It used to be a rounded cube, but it's not going to be anymore. So we can, yeah, we don't need to do this anymore. I'll get back to my rounded cube when I can generate an FBX from it. All right, cool. So, looks like the color is, yeah, the specular colors. Okay, there we go. Let's make this like black pretty much. Sphere specular. Okay, so yeah, so we can probably add, like, we have access to binomals and tangents in the shader, I assume. A good, easy way to check that out now is by first of all having a binomial and a tangent input here, having a binomial I'm not going to translate them. Binomial and tangent here. And let's output them. Color equals spec4. Oh, color.xyz equals binomial. I assume this will work. Or not compile. Binomial undefined variable. Yes, you're correct, because it's fsin.binomial. Okay, that looks pretty legit to me. I mean, it's not perfect. Let's do that the other way around, maybe. Debug menu is control tab. Okay, there you go. Binomals are indeed there. And tangents, which are going to look basically the same, are also there. Maybe. Maybe not. Tangent. Yay! Look at that. Alright, I'm pretty happy, to be honest. Because we've got all the stuff now. Alright, I'm going to wrap up the live stream because this was very successful, to be honest. So, yay. I'm going to commit this stuff now. Versioner. Status. If you guys have no idea what I'm using a version control system called Versioner. It's written by Eat Play Hate, who you might have seen in the chat. It's on GitHub as well. github.com/eatplayhate/versioner, and it is pretty awesome as a secondary version control system, or as a primary. It's just that it doesn't have GitHub, so yeah. All right, so what do I need to add? I don't really want to. In fact, one thing that I did want to do was add to the excludes. So this is how you oh, I already did bin debug. This is how you can exclude directories from Versioner. It's like a get ignore. So, let's see what we got here. I can probably just add everything. I've got a lot of changes even in layer and stuff. Oh, yeah, I did. It's because I added stuff like resizing windows to actually work, and yeah, it's looking like, oh, that's not, yeah, I don't want any of this stuff. That was a JSON file. Okay. Let's not commit any of that. So back to the JSON file. Versioner. All right. So extensions, we don't want IOBJ. We don't want IPDB. We don't want PDB. Let's run that again. Oops, not that. That. All right, then they're gone. We don't want SDF or OpenDB. Build force. Okay, anything that's /obj, like we just pretty much will not want. So like obj/debug, for example, I just don't like sandbox cs/obj. I don't care about. What are those weird? Okay, yep. None of the none of the precompiled header paths. We don't want any of that. All right. Yep. Yeah, I don't mind committing that, I guess. So let's record via meta. I'll commit it, I guess. Via meta. I'll just record everything. Screw it. We're doing it. And I did record everything that's, yeah. Versioner commit. Finished. SPM. Build tool for now. Yay. All right, done. And versioner push. Sorry, you guys aren't gonna get that. Lols. All right, so that's pretty much the end of the stream. Nah, versioner is pretty rock solid. Hasn't let me down yet. Although there is actually a bug that I discovered today, which I will tell you later. 8play8. All right, guys. Well, thanks for watching. Hope you enjoyed. Tomorrow is Friday. I probably won't be streaming for the rest of the weekend or anything like that. Maybe next week. I'll try and do one stream per week though, because I want to be able to. Versioner can be local, and it's a distributed version control system, so it does have a server thing. But yeah, like 8play8 just. Yeah, you can probably just 8play8 will tell you more about this since he wrote it. But anyway, thanks for watching, guys. Hope you enjoyed. Be sure to join the Slack. If you go to slack.thechannel.com, you will be able to continue talking with everyone you were talking in chat when the live stream finishes, because it's just like a massive instant messenger where you can talk with anyone at any time. Yeah, it's really cool. And then there's a Sparky channel there, and the thing is, on my Slack in the Sparky channel, I'm kind of lately I've been treating it almost like a little blog. So every time like I'm working on Sparky and I do something new and there's like a cool screenshot to show off, I'll pop it in there. Okay, and you also have the bonus of having it play at the Slack, in the Slack. So yeah, so if you want to keep up to date with Sparky and keep talking about it and all that stuff, then slack.thetrainer.com. I'm so tired, sorry. Slack.thetrainer.com. Join the Sparky channel, and yes, and I'll be posting my progress and all that stuff when I'm working on it offline. But anyway, thanks for watching, guys. Hope you enjoyed this video or this stream. This will be up on youtube.com/Cherno archive as well. So you can catch it there if you didn't catch the entire stream, because it'll be uploaded there. All right, thanks for watching, guys. See you next time, and have a good night or day. Yeah, there'll be a Sparky devlog on Monday, of course. So yeah, all right, see you guys later. Bye. Whoom.